Hi, so my name is Kartik Kumar Pandya. This is the resubmission video of target 7b. So on my prior video, I have used the least complicated equation, but now I am taking a good problematic nasty equation. That's a good enough, I think. Probably we'll see. So in this video, I was going to demonstrate the target 7b. Target 7b says that I can convert and or not Boolean expression into the equivalent circuit using only NAND gates. NAND gates, yeah. So for the target 7b, I am taking the equation AB dash, not the, I'm taking red color, AB dash plus BC prime A prime C plus A prime B plus B prime C prime and whole prime. Okay, I think that is good enough for target 7b. So let's make the first circuit using all the AND, OR and NOT gate. So we have three inputs A, B, C, F. So first is A. So we will gonna use the prime in all of them. So I'm just putting the NOT gate in every input. So first is A, B prime. So B prime, A. This is NAND. So A, B prime. Then second is B, C prime. B, C prime. Okay, they both has a plus. So OR. This is OR. Believe this is OR. And then for the second bracket, first is A prime C downwards. A prime C, A and prime, A prime and C, then A prime B, they both has a plus, so like OR, and then this has an AND, so they gonna multiply by AND. So we create the equation, this is here, then we have B prime C prime. So B prime C prime, and then the both has a OR and the prime. Because of this prime we got the F. This looks nasty, but this is not. This simpler equation. And then we have a universal equivalent of AND. So AND we can write it as, and the OR we can write it as yeah. This is the equation we will gonna use this for circuit 2. So the circuit 2 we are gonna replacing these terms, this AND with this and the OR with this. Okay, so I'll write a new circuit, that's fine. A, B, C, yeah. So first this is AND, two ORs and. Okay, perfect. So I'm writing the equation once again. A B prime plus B C prime A prime C, A prime D plus B prime C prime whole prime. Okay, so the first is A B prime. It really has it is using AND, but we will gonna replace AND with this thing. Okay, then BC prime, once again AND, we're gonna replace it with this thing. Then it has an OR in between, so we will gonna replace OR with this thing. Okay, yeah, and then in the second bracket we have A prime C, A prime C. We're gonna replace it and with this thing. Then A prime D, A prime B, A prime B. It will be messy, yeah. I have to use the whiteboard instead, but that's fine. Then the OR, once again the OR will be like this. And then the B prime C prime, B prime C prime, once again this thing. Okay, and this both has the AND and this both has a OR. And then on this side it will be has R. That's fine. And now we have to cancel the two knots. So for that I have to write it very cleanly, so I'll just write this whole cleanly. Okay, so this is the more cleaner circuit than this. So now we have to just cancel the knots, like there are two knots, like, yeah. So we will want to start with here, this two gone, this two gone, this two is also gone, here, yeah, this two also gone, also gone. Okay, am I missing anything? No, I think that's it, yeah. So it will be reduced too much. The knots will be gone, not fully, but yeah. And then we have to write it like in the new one, the third circuit. It will be more simpler. So A, B, C. I'm just gonna write it down and then I'm gonna show you, okay? So this is my final circuit with NAND gates. So it was crucial. It was more lengthy because I have choose this equation. So this is the circuit with all the gates with AND or NOT. Then we have the equivalent thing. This is the AND equivalent, this is the OR equivalent. And then we got this circuit and we have just eliminated the NOT gates. Those are dual, like dual, like this. And then finally we got our NAND gates only circuit. Yeah, so that was all from my side. Thank you for watching the video. Thank you.